Hi friends, today I am going to discuss what are bitwise operators in Java. Bitwise operators are AND operator, OR operator, XOR operators, and NOT operator. Bitwise operators in Java allow manipulation of individual bits of integer data types. These operators are particularly useful in low-level programming, cryptography, bit masking, and performance optimization. Let us see what is AND operator. AND operator compares each bit of two numbers and returns 1 if both the bits are 1, otherwise 0. If we discuss in terms of Boolean, returns true if both the values are true, otherwise it returns false. Let's see truth table. 0 and 1 return 0. 0 and 0 return 0. 1 and 1 returns 1 because here both the values are 1. 1 and 0 returns 0. For example, true and false returns false. Only if both the values are true, then only AND operator returns true. Otherwise, it returns false. And 6 and 5. Let's see what is the output of 6 and 5. The binary representation of 6 is 110 and binary representation of 5 is 101. Let's do AND operation in between individual bits of these corresponding numbers. 0 and 1 is 0. We should go from right to left. 0 and 1 is 0. 1 and 0 also 0. 1 and 1, 1. Result is 100. The decimal representation of 100 is 4. So the output is 4. And let's see what is OR operator. OR operators compares each bit of two numbers and returns 1 if at least one of the bits is 1. Otherwise 0. If at least one value is true, it returns true. Otherwise it returns false. Let's see truth table. 0 or 1 returns 1. 0 or 0 returns 0. Because here no bit is 1, so it returns 0. 1 or 1 returns 1. 1 or 0 returns 1. Because here one bit is 1. For example, true or false returns true. Because here one value is true, so if at least one value is true, it returns true in OR operator. Let's see what is the value of 6 or 5. Let's find. The binary representation of 6 is 110 and binary representation of 5 is 101. So we have to find the OR operation in between each and every bit of corresponding numbers. So 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is also 1. So the decimal representation of 111 is 7. So it outputs 7. So let's see what is XOR operator. XOR operators compares each bit of two numbers and returns 1 if the both bits are different, otherwise 0. If the both values are different, that is, if one value is true and another value is false, it returns true. If both are true, it returns false. If both are false, it returns false. So that is, if both are same, XOR operators returns 0. Here 0 XOR 1. Here both are different, so it returns 1. 0 XOR 0. Here both the values are same, it returns 0. 1 XOR 1. Here both the values are same, so it returns 0. 1 XOR 0. Here both the values are different, so it returns 1. Let's see an example. True XOR false. Here both the values are different, so XOR operator returns true. And 6 XOR 5. The binary representation of 6 is 110. Binary representation of 5 is 101. So let's do the XOR operator for individual bits. 0 XOR 1. Here both are different, so it returns 1. 1 XOR 0. Here both are different, so it returns 1. 1 XOR 1. Here both the bits are same, so it returns 0. The decimal representation of 0, 1, 1 is 3, so 6 XOR 5 outputs as 3. So let's go for NOT operator. NOT operator inverts the bits of a number. That is, 0 becomes 1 and 1 becomes 0. We can apply this operator only for integer type, not for Boolean type. For example, not true raises a compile time error because we should not apply not operator for Boolean types. Not 4 returns -5. Let's see how it returns -5. The value of 4 is, the binary value of 4 is 0000 0100. So these are 32 bits. Then in order to find not, we have to invert all the bits. So after inverting, 0 becomes 1, 0 becomes 1, and so on up to 0 becomes 1, 1 becomes 0, 0 becomes 1, 0 becomes 1. So after inverting, the binary representation becomes 1, 1, 1, 1, and so on up to 1, 0, 1, 1. So after inverting, the first bit is called most significant bit. It decides the what is the sign of output. If most significant bit is 1, the sign of output is negative. If most significant bit is 0, the sign of output is positive. So here not 4 output has negative number. So as we know that in memory negative numbers are stored in the form of 2's complement. So we have to find 2's complement for this number. So we should find 2's complement for this number. Then find the 2's complement. 2's complement in the sense 1's complement plus 1 for above representation excluding MSB, most significant bit. First we have to find 1's complement. So 1's complement of this number is 0, 0, 0 and so on up to 0, 1, 0, 0. And then add 1 in order to get 2's complement. After adding 1, it becomes 1, 0, 1. The decimal representation of this value is 5. So our most significant bit is 1. So 1 means negative. The output is -5. -5 is the output. So in order to find not values for integer, first we have to invert the number, then we have to find the 2's complement. Note, the most significant bit acts as a sign bit. 0 means positive, 1 means negative. Positive numbers will be represented directly in the memory. Negative numbers will be represented indirectly in the memory in 2's complement form. We go for what is Boolean complement operator. We can apply this operator only for Boolean types, not for integer types. For example, complement operator 6 raises compile time error because we should not apply this for integer types. Complement operator false returns true. Same as complement operator true returns false. We can apply complement operator only for Boolean types. And some conclusions. And or XOR applicable for both Boolean and integral types. And not operator applicable for only integral types but not for Boolean. And complement operator applicable only for Boolean but not for integral. We should remember this. And now we go for exercise. Please pause the video and answer the questions. First question. What is the output of the following Java code? 5 and 3. The binary representation of 5 is 101 and binary representation of 3 is 011. So to find AND operation in between these, we have to find AND operation for individual bits. So we'll go for right to left. 1 and 1 return 1 and 1. The both the bits are same. So 1 and 1 is 1. And 0 and 1. Here both the bits are different. So it return 0. And 1 and 0. 1 and 0. Here both the bits are different. So it returns 0. So 001 is a result and the decimal representation of 001 is 1. So option D is correct answer. Second question. What will be the output of the following Java code? system.out.println of true or false. Here in OR operator, if at least one bit is true or if at least one bit is 1, so the output is true. So option A is correct answer. What is the result of the following Java statement? 5 XOR 3. The binary representation of 5 is 101 and binary representation of 3 is 1011. So in XOR, if both the bits are different, then only returns 1. If both the bits are same, it returns 0. So here both the different bits are same, it returns 0. And second, 0 XOR 1, it returns 1 because both the bits are different. 1 XOR 0, it also returns 1. So the decimal representation of 110 is 6. So 5 XOR 3 return 6. Option C is correct. Fourth question. What will happen if you try to compile the following Java statement? Not true. Not true means we should not apply not operator for Boolean type, so it raises a compile time error. Compilation error. Fifth question. The bitwise AND operator returns 1 only if we know that the output of AND operator is 1 only if both the bits are 1. So option B is correct. Thank you. Please like, share and subscribe for more videos.